Hello, my name is Jonas Serfoner with Schweitzer Engineering Laboratories, and today I'm going to give you an overview of the 751 settings file. And I'm going to show you how to set an overcurrent and time overcurrent element. Generally speaking, the settings are laid out in a tree structure format. The global is the overall settings that are impacting all of the other settings groups that are available in the settings file. We have 4 different groups available. By default, the active group that needs to be programmed is group 1. All the other groups are inactive. If you go further down, you can see the front panel. This is the section that is going to program an LED on the front of the device, to program the LCD screen, or to program a push button. The report section in the settings file is responsible for any event reporting capabilities, such as triggering an event report without the relay tripping, logging SER data, and programming which of the relay word bits are included in this. And below the report, you have the various ports that are available on the 751 relay that can be configured. In particular, what we're going to talk about is setting a 50 and a 51 relay, which are fairly common protection elements to replace an electromechanical relay with. Now, to do that, we can do a Control F and search for the particular setting that we're trying to program. So here, for example, I'm typing in the CTR setting for the current transformer ratio. On the bottom, it gives me the search results, and you can see it's for all of the multiple groups. We only need to go into the group 1 because this is the active group. The CT ratio by default for the 751 settings file is 120. Let's assume the CT ratio of the CT that's installed in the field is in fact 120, so we're not going to modify this. Now, to navigate and set the overcurrent element and the time overcurrent element, we navigate to group 1, set 1, and overcurrent elements. In here, we have the option to program a maximum phase overcurrent, a neutral overcurrent, a residual overcurrent, and a negative sequence overcurrent element. We're going to do a maximum phase overcurrent. So the 50 P1P is the setting threshold of the phase overcurrent trip pickup in secondary amps. So if we know the primary amps current, we need to divide it by the CT ratio in order to get the 50 P1P setting. So let's just assume that the 50 P1P secondary current that we're experiencing for a fault is 15 amps. The 50 P1D is a definite time delay that can be added to the instantaneous overcurrent element. For us, let's say we don't want any delay, so we're going to trip instantaneous and not modify it and keep it at 0. The 50 P1TC is the torque control that can block the operation of the 50 element. For our case, we're going to set it to 1 to continuously have it active. This is essentially as the settings you need to consider for setting an overcurrent element. Now, if you want to set a 51 element, a time overcurrent element, you navigate in the group 1, set 1 to time overcurrent elements, and here you have the option of a phase time overcurrent element, a maximum phase time overcurrent element, the negative sequence time overcurrent element, neutral and residual time overcurrent element. Just to illustrate the simplicity, we're going to set a phase time overcurrent element. And it's fairly similar to the 50 element, only that the time overcurrent is dependent on a particular curve. Just like electromechanical relays, the time overcurrent element inside of the SEL relay chooses a curve, and these can be the IEC curves or the ANSI curves of U1, U2, U3, U4, and U5. If you're replacing or doing a retrofit application, you would want to select the curve that the electromechanical relay had previously. So let's assume the curve of the electromechanical relay was a U3. The time over current trip pickup is also in secondary amps. Let's assume, based on the previous knowledge that we have available from the fault studies that we did and the retrofit, that our secondary current that we want the 51 element to start timing on is 10 amps. The 51 ATD is the time over current time dial setting that needs to be calculated and set accordingly. We're going to assume a value that we have received of 5. The electromechanical reset delay is important to consider when you're doing a coordination of multiple relays, such as microprocessor relays, with electromechanicals. Because the reset time of electromechanicals is based on an electromechanical delayed reset, you would also want to enable the electromechanical reset feature in the 751 relay. So let's assume we're coordinating with other electromechanical relays that have been installed. So we set the setting to yes. This is the basic settings that it takes to configure a 50 and a 51 element. For further information on the 751 and our other relays, please go to the SEL webpage on selinc.com. Thank you for watching.